It's kind of strange that that happens, but it definitely does.
You what?
I made so many things.
Yeah. Mine's
A little
$57 right now.
thing, like,
Oh my God.
you know?
No,
And
like,
then a sugar bowl,
next
like, has a
semester.
lid on it. Made a mug.
Oh, God dang, I had a ball, but actually so like.
Yeah, I glazed it all today, so it's done next time. What else am I doing? I'm so excited. I am so excited. I'm gonna bring it into this house. I'm gonna get a big old thing and I'm gonna pop it on the desk individually.
Oh,
Unless the glazes turn out ugly and
so
then
you get to fire it next week?
What?
You're gonna fire it next week? Or so you gonna fire it
Well,
this
I
week?
just
anyway?
put them on the shelf, so I'm hoping he'll fire them, hopefully by tomorrow.
Yeah.
And then I'll get them on Tuesday. But I don't know. And then if the glazes turn out ugly, I'll just throw them on the ground and you guys won't see anything.
Gotta break stuff to make stuff, right?
Yeah. I hate glazing. Mr. B's always like, you need to glaze your pieces. And I'm like, it's so annoying to sit there and watch it dry. Like, I could be doing so much with the time.
Patience is a virtue. All right, well, welcome back. I wanted to take a second and just kind of walk through yesterday. Because I know you had to do it at home, and I know that there was some new stuff that happened. So if you could take out what you wrote down as you worked through stuff yesterday, I just want to make sure that you feel okay with it. But I really want to give you as much time today as possible to just practice. Just make sure you can do basically the two kind of bigger ideas that show up here. Okay. And so what we started to see yesterday with 2.5 is that now that we have complex numbers that we can deal with, any polynomial of degree n has exactly n complex roots, and we can find every single one of them, which is really, really nice. And some of them might just be real, which is great. Some of them might just be imaginary, but they're all complex. Okay, so that a plus bi, if we want to do another. And because we have complex roots, and I know exactly how many of them there are, now I can completely factor every polynomial into that many factors. Right? We have some leading coefficient up front, and if you just got x minus a complex number, x minus a complex number, however many there are, we can just write them all down. Right? That linear factorization theorem comes in really, really, really nice. Ignore that sum of d. Okay. And so once we have that, we said, all right, let's just try this thing. Let's see if we can like put this thing to use and say, okay, if I have this degree 5 polynomial, how many complex zeros are there? 5. And I can find every single one of them now, right? I have a way to do that. And we said, well, you know what? The easiest place to start at, let's find the rational ones first, right? And we jumped into our calculator and we said, okay, positive 8 at the end, positive 1 at the beginning. So 1, 2, 4, and 8 are our options. We ran through that and we said, okay, great. Which ones actually worked? We found a couple, right? We found 1, -2. But if we didn't graph it, we wouldn't have known that 1 also worked again, right? Because this graph eventually, if we gave ourselves a chance to look at it, looked like this, right? Where right there is -2 and right there is 1. And when we worked through synthetic division, we got to this cubic that, sure, it was factorable by factoring by grouping, and we got kind of lucky that it worked out that way. But we might be able to save ourselves so much time by, if you're given a function, the first thing to do, let's graph it. Let's look at it and see. Yeah?
Well, I mean, like, why list the possible rational zeros? Just do that.
Because what if we don't have this? So I'm just trying to prepare you for both scenarios. Like question B, like part B is really more of a, you know what, I don't know where to start because I don't have a calculator. Let's make sure, and that's why I kind of keep bringing it up, let's make sure we have that down comfortably so that if the time comes where I say, all right, no calculators, let's make sure we know what the rationalist theorem allows us to do, then we can do that. But you're right. I've got a calculator that I can plug in and look at, and I see it go exactly through -2 and exactly through 1, and part B isn't really all that necessary. I agree with that. The thing that might come up, though, is it might hit in between tick marks. And so if the answer is like 17/4, it might be hard to see that visually, and having a list to look at might make that just a little bit easier, but absolutely. And so we did a bunch of synthetic division, and having that repeated 0 just made it so much easier to get ourselves down to that quadratic. But once we got down to the quadratic, right, it was time to solve for those last ones. And now that we have the ability to find complex zeros and write them as a plus bi, things just look a whole bunch nicer. And now I can write them as products of linear factors. There's 5 complex zeros. I had 5 factors. Now, if you write it as right, x minus 1 and x minus 1 and blah, 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 that's fine. If you want to write that as x minus 1 squared, that's cool too. Okay? It's still a linear factor. It happens. So I'm flexible either way. So you're going to see in the solutions for the work that we're going to start today. Let's not do until tomorrow, because it's going to take you some time to work through it. Sometimes I write it just, here's my 5 factors. And sometimes I write it a little bit more efficiently because I want to show you that either one's fine. I'm cool either way. That was quick. Questions about that? So hopefully yesterday went okay and that you were able to kind of follow along with me. What we'll do today as well, we did another one, right? Is we'll also be reminded that complex zeros always come in pairs. Because they're coming from these unfactorable quadratics that have values for certainly A, right, because I need an x squared, and then B or C as well, because unfactorable, so probably both B and C. And we get these quadratic formula results that have an, a plus or minus in between. And so what we want to remember is that if A plus BI is a 0, and obviously we don't want we want the imaginary part to exist because they're complex. So B is not 0 in this case. If A plus BI is a 0, then its conjugate A minus BI is always going to be a 0 as well. And we looked at, I think, just the one example, right? And look, they wrote -1 twice. When you write your zeros out and you have them show up more than once, write them more than once. And you're going to see me do that as well. I'm going to try to write down how many times that 0 shows up so I know how many factors to do. But then they only told us way back over here that 3i is one of the zeros. But if I have an imaginary part that exists in one of my zeros, if I have a complex 0 with a non-zero b value, if 3i is a 0, what's the other one? -3i. Switch the sign of the imaginary part. Really, it's 0 plus 3i, right? So we have 0 minus. Right? And that's 2.5 in that nutshell. Okay. And so what I want to give you today is a time in class to put a really, really big dent in problems that look like these kinds of problems. Okay. So we have like 35, 40 something minutes where I want to just say, go ahead, try this stuff out. Okay. And so if you're at home listening to me right now, first of all, thank you very much. Go to today's announcement. And if you guys are here right now and you want to pull it up on your phone, I'm going to project it as well. But if you want to have it right in front of you, if you go to today's announcement on Canvas, I put a lot of stuff on here, actually. And by the way, people at home, if I lose you, since the internet has been kind of stingy here today. right here. Classwork, 2.5. It's worth 10 points because it's longer, okay? I did the solutions last night. It took me almost an hour to do the solutions. So you're not gonna finish it in class today, okay? That's why I'm giving you all of tomorrow to do it as well, which means you don't have to show up live tomorrow, okay? Optional office hours in case you're struggling. If you wanna work through some of this stuff together, I'll put those times up on my announcement for tomorrow. But I will send out a homework. I don't know if I've written it already, but if I haven't, I'm pretty close to having it either later today or early on Friday. That for you guys here will be due by the time you, like by midnight on Monday. Right, so kind of like I'm giving you your work for Monday ahead of time, so that if you wanted to get started on it, you can. Okay? But it's gonna be a bunch shorter. Classwork 2.5 is long. Okay, it took me 6 pages, like 3 pages front back, to do my solution. But that's me taking my time and writing them all out. Okay. 2.5 homework 2.5 will be a bunch shorter, just like 1 or 2 of these and 1 or 2 of those, just to make sure that we kind of bring that knowledge with us. Okay, so optional office hours for you tomorrow. Right, so purely here's us, right? C6C forums, you have 1 week. Do not have them in by next Thursday. You do not get credit for this. Okay. Classwork 2.5. That's right here. Okay. And it's the same kinds of questions. So part 1, right, for each of the following functions, do that whole A through F. And I've listed 5. Okay. You only have to do the first 4. Okay. Z of X, for all you brave souls out there, is a challenge. Now, I'm not saying that it's all that much more difficult. It's just larger degrees, so you just have more to do. Okay, but rational roots theorem is not going to be all that tough with 1, 5, and 25. Okay. Part 2 works through kind of that reverse thing, right? Start with the zeros, get you to a function kind of thing, where sometimes I give you both of them, so you don't have to add anything, right? I negative I, cool. 4 and negative 4, I, great. But if I only give you one of them, you got to make sure you add the other one in there. If I only give you one of them, make sure you go back in, you adjust your function to have all. Okay, so one more thing to say, and then I will shut up. I'll let you work. Part 1, when I say completely factored, you can have i's in there. That's fine. Just make sure you're doing x minus all of it and getting rid of those brackets. Okay. But for part 2, real coefficients only. Which means that when you write the factors of this, like x minus 2, x minus I, and x plus I, you're going to have to multiply those 2 factors together to get rid of your I values. Now, you don't have to multiply it all together. Okay? You have to multiply these together so that your I values disappear. Plus xi minus xi gone, negative I squared is plus 1. And that's fine. That's why I boxed that one in. If you want to keep going and go to standard form, great. Keep going. You don't have to. Okay, so I just wanted to show you that. And that's the other thing. I've done all of the solutions already. Okay, and those solutions just too soon. Solutions are posted here. And so I think you should do a couple things. Number 1, either open up that classwork or I'll just project it back up again. But number 2, open up the answers to. And make sure that as you work through number 1, you're getting it right. I don't want you to work through the first 4 and realize you screwed up option C every single time you go back to things. Okay. And also have calculators out, because you want to be able to look at those graphs and make sure that if you have repeated zeros, you can notice that, hey, this one's going to happen twice, or You know, that one's gonna happen 3 times, and that one's gonna happen twice, or whatever it is, okay? And the next 37.5 minutes is all you. I'm gonna let you get out in front of me a little bit. And I'm gonna start kind of working my way around and just peeking at how you're doing and giving you pieces of advice as to what you can improve on, if anything, okay? So I'm gonna project this so you don't have to open that up. So maybe you just open up the solutions in front of you, but you don't peek until you're ready. It's not gonna do you much good if you just copy down my answers. Now, will I know if you just copy down my answers? No, not today, not tomorrow, but on the chapter 2 test in a couple weeks, I will definitely know if you're not doing this stuff on your own, and that's gonna count for way more. Okay, so do what you need to do to feel confident. Okay, option, again, question 5, not required. Skip it if you want. Take the challenge if you're interested. I made it nice. It's gonna work out for your real zeros. The ones with the imaginary parts are gross. But the quadratic isn't bad once you get there. It's just solving it doesn't work out all that pretty. But that's okay. That's life. All right, time is yours. Folks at home, same thing. I am here. I'm kind of like dedicating this time for you to have, like, you're in my ear. So if you work through this stuff and you have questions, now's a great time to do that. Okay. If you wanna tune off and say, you know what, I'm just gonna do this over the next couple days, that's cool too. You don't have to stick around. But here you are anyway. Let's work through some stuff together. I'm happy to help you if I can. But really all you're gonna do is you're gonna be talking to people that are here with what they can do. Any help? Just let me know. Okay. I have to listen to me. I have the solutions up on my laptop up there as well. So if you want me to unfreeze it so you can see the answers, if you don't have it pulled up, that's okay. I also have the physical copy. Want clarity about something, you want me to reteach something, just ask. No shame. This is learning. That's what it's all about. You got it. That's some time to learn. And if you finish it, great, but it's not due until tomorrow. This is classwork 2.5. Homework 2.5 I will send out to you due Monday. And cohort A at home, you guys listening right now, that'll be due by the start of class. So Sunday midnight, but the morning's fine. But it'll be short. Just something a little.
easy.
Yeah.
Do we have to do the step that's like splits the 16 and the -1 under the square root?
No, I don't think so. I just wanted to show anybody that wanted to see where that came from, how I'm doing that. So that's like that's a super slow version of that. If you say x squared equals -16, x equals plus or minus 4i, awesome.
Okay.
Let that happen quickly. I'm totally cool with that. I just some of us are like to see just one step at a time and really make sure that they understand where it's coming from, so that if they weren't sure how to start simplifying those negative square roots, maybe my answer would kind of guide them through that. But no, you can definitely make that happen a whole lot faster. And I think even if you look at my work for number 2, like I simplified that. Square root of -36, boom, 6i, right? Makes that happen a whole lot faster. So yeah, work as quickly as you can, but still kind of logically. Like, don't make me guess through any of it as to how you got there.
Okay.
You know what I mean?
Yeah.
And that's a tricky balance. Like, where is the in between? I know. So more work is always safer than less work.
Okay.
But if it's something that we're doing in class, just like you just did, you just ask the question, is this enough? Am I doing enough to show you my work? That's never a bad question.
All right. Thank you.
Mr. Rosengren?
Yeah.
Okay, so number 1D.
Yeah.
So after you do synthetic division, like I have 1, 0, 16, so that's 3 terms. I guess I just thought like 0x means that that's just 0, but you still have x squared plus 16, so you have to use that as a value.
So the 0 in synthetic division is the coefficient for x, which is what you said, right? So we start with the cubic and we get ourselves to here, right? So that's quadratic. So that's my coefficient for x squared, that's my coefficient for x, and that's my constant. So, but I don't need a 0x, so I'll just call it x squared plus 16. Because like the whole point in me trying to pull out that 0 that I know works, I know 2 is going to do what I want, it's going to get me a remainder of 0. So that helps me start factoring. Because I want to get to that completely factored form. So this is the coefficients of whatever is left when I factor out the x minus 2.
Got it.
Does that make sense?
Yes, thank you.
And so it's kind of like this in-between factoring. That's why like this is only part D. It says, to use synthetic division along here to start factoring. We can't completely factor until we find all of the remaining zeros that go with this one, right? So I'll take x squared plus 16, set it equal to 0, and solve it any way I know how. And since there's only one x in that equation, I can just solve for it directly, subtract 16, take the square root, plus minus. Sneaky stuff. Put 1 plus or minus. Put all your numbers up in parentheses or in brackets or something, so I know that you know that everything is plus or minus. This is where you write plus or minus all over and over again. But I know that you do all of those. expression. You're like, subtracting 16, and then where does it go, right? You want to have that balance. I mean, obviously, you know what you're doing, but it would be silly to lose points on just like formatting and stuff like that. And if you start to get more comfortable with it and you get yourself from here to here without that step in between, that's cool. The thing you want to be careful of is look what you wrote. X squared equals plus or minus square root of negative 16, right? You took the square root of the right, make sure, yeah, it's just silly little things, but about balance and making sure that if I didn't know how to figure out for this, I should be able to follow your work logically. Set it equals 0. Right. X equals. So I know you're solving that equation. Now, when you are doing kind of that arithmetic, you have to figure out that can be 36. Be careful, just like putting an equal sign, because what it seems like is that you're connecting all of this and saying that the whole thing is equal to that. No, a super great way to write that otherwise, like for me, I just kind of like brought the rest with me when I connected it all together. I said, okay, I've got 8/2, and you wrote just 8/2, and you can call it 4, like right now, call it 4 plus or minus the square root of negative 36/2.
Yeah.
Or like write the whole fraction again, like you want to have this.
That's what he got.
Train of equality, right? It starts with the engine and ends with the boost, and everything's connected along the way. So, if you're just like simplifying this so that you can work a little bit more efficiently,
Made a nice crash.
just
That's
be
what he got.
careful how you write that
That's what he got on
down
there.
so that when I look left to right, kind of like when you said X squared equals plus or minus the square root of negative 16, you didn't adjust the left
Oh,
side.
never mind. I
Right?
see
The
what I-
equations you need to
I get it. I didn't make the 16 negative. Wait, so was it?
These are all available for you guys.
Yeah, it's plus 4.
Minus 4 and plus 4, or plus 4 and minus 4?
Plus 4 and 1.
They're both high.
Yeah.
Makes sense. Oh, yeah. Oh, no, I just think
We're gonna have to work on that. Your function so I know that you're rewriting the function, like you're starting to exactly this.
Yeah.
Good, and I don't mind that. That's all right. That's okay. It's better than like trying to sneak it in up here or like always. Looks really good. Nice. I would say like X equals, so that we know what our like what those numbers represent. They represent potential X values or actual X values. So that's really good. So you don't have to go as slowly as I did. If you start to get more comfortable with like the transition from this to there, and that's okay. So you can start to be more efficient as you get more comfortable dealing with these words.
I really want to go.
And that's okay. Like, so more work is better.
Mhm.
Less work is dangerous, right? Because if you write less work and something goes wrong, you're magnifying the loss of points because I only have so much to look at. So if I've got a question worth 10 points, you show me 10 steps. Well, then every question, like every step along the way might be worth 1 point-ish, right?
Yeah.
But if you only show me 5 steps, everything's worth 2, potentially. I'm just kind of making stuff
Yeah.
up, but you know, you don't want to lose more points than you have to for a mistake that if you had just shown like 1 extra step, you would have gotten that point back or something along the line. I like it. How do you feel about it? So far, so good?
Yeah.
Um,
I don't know if they get harder.
They do, yeah, so easiest, next easiest for sure, like, because I made it work out really, really nicely where there's only 1 x in that problem, so you can solve it directly.
Yeah.
This one, the quadratic formula worked out really nice because you have the square root of -36, and oh, look, they're both over 2, and I can simplify both
Yeah.
of those, right? So it'll definitely get harder as we go. So this is- Riley, you're seeing true. Thank you. Yeah, question. Huh? Good question. Okay, so if the 0 answer is x equals 2, what I want to try to come up with is an expression that would create 0 by me dropping in the number 2. And so if I left it as x plus 2, I don't really need it. If I left it as x plus 2 and I drop in 2, well, that's not 0, that's 4, right? So let's switch the sign of whatever our answer is to come up with the factor that got us to that 0. Good question. All right, Sam, let's see how we do.
So far, I'm a little confused on like why we did on this one the x minus and then the x minus we already have it here. Like this one was just the plus or minus 4.
Okay, but look at 2 things. Number 1, when we have zeros that we know, the factors that they come from change of sign, right? So your answer is x equals 2. Factor that they came from was x minus 2. Right? X equals -5, okay, x plus 5. So I always want to switch the sign of the 0 that I've got. Now, when you talk about the plus 4i and the minus 4i, and then just kind of bringing that down, plus 4i minus 4i, look at how I actually ended up writing it. I tried to write it in the order that I found. So positive 2 was a 0, so x minus 2, all right? Positive 4i, x minus 4i. Negative 4i, x plus 4i. So I'm still switching the sign, and I'm really subtracting, like this is x minus negative 4i.
Yeah.
So that when I get to something, I mean, even with this, right, this is the one we're looking at, right? I've got 4 plus 3i, and that's my complex 0. This is c sub 1, right? But it's supposed to be x minus that to make that work. And so I want to subtract everything in there. So I better at least get rid of those inner set of parentheses, distribute that subtraction, if you will, and then you've got 4 minus 3i, but I want to subtract that, so it's x minus 4 plus.
Okay, that makes sense.
Drop an equal sign right there because you're connecting x equals.
Okay, gotcha.
Make sure you keep that train of equality going. Oh, but everything looks good there. Looks good. Nice.
Thank you.
Good and organized. Makes it so easy. This makes life so much better. Good. And if you're like, we get comfortable to the point where you can say the square root of -16 is 4i, cool. Like I don't necessarily need that step in between as we start to get more and more comfortable. So whatever you think is good for you, nice. I actually kind of like that. Like, I know I need at least, I need two more, right? And so putting those spots there reminds you of how. Now,
Yeah, I messed it up initially because I messed up that because I forgot to put the negative there. So
I got you. Yeah, there's four. Okay. So, so you know that it's going to turn out like that. So
instead of
write it right there, like put plus or minus 4i in that step where I ask you to find the complex zeros. Simplify there and make sure you kind of bring that down. Cool. One other thing I would suggest. So when you worked vertically like this, it works great. But you were working horizontally with the quadratic formula. Put x equals, x equals, x equals. Then you forgot. Oh yeah. So either just put an equal sign to connect this x there, or just put another x equal. Otherwise, it's good. How are you feeling?
Pretty good.
Okay. Struggling a little bit somewhere.
I feel like
These get harder.
these aren't right. Like I'm noticing.
I know. So we're dealing with harder and harder stuff. So number one is an easy one. Number two gets a little bit harder. Number three really kind of takes off the next level.
Yeah.
So and it really is because of this. It's the first time in these that we saw our rational zero actually give a fraction.
Yeah.
That's what makes this hard.
You're gonna learn.
And that's why
Okay,
I'm putting this
one
is where you know.
No, I did. I got
Because
one.
I like your
One.
idea. It's like saying, you know what, if I've got this,
Oh, yeah, that sounds like you gave
this is zero, like it's gonna come from that.
Oh, yeah, I
It's
got
gonna
it.
be a long division, which is great.
Ooh, I'm learning.
Not as nice as we hoped, but that's the reality, and that's okay. So there's the. You say, all right, well, I'm gonna figure out what zero goes with that and factor it so I can.
Yeah, which is really all over the place.
But you're doing a good job, because and it's not as organized as maybe we would like, but it's only because you're starting to run out of space, right? And I'll make sure that come whatever test we decide to do, you have a ton of empty space, so that we're not missing. The only suggestion that I would have is because it's A plus BI, don't put the I in between the 2 and the radical 3. Put the I at the end.
Oh, okay.
But the thing you want to remember, like when you simplify the square root of negative 12 into 2 radical 3, I, that was part of the quadratic formula where it still had a 2 in the denominator.
Oh, yeah. Okay.
So this 2 gets divided by 2, but so does that.
Okay.
Okay. And what some people do instead of making one big fraction is they'll separate the real part and the irrational part of the complex form. So they'll have 2 over 2 plus or minus this over 2. And so they're kind of simplifying the 2 fractions separately. So that maybe, because what some people will do is they'll like go like that. And they'll forget.
Hey, man.
Don't do that, Alex.
Like me.
Like you, but you're not alone. You are definitely not alone.
Yeah.
I don't know, well, I don't understand this, but, why did you in this one do
Yeah.
that?
So I did both.
Okay.
What I wanted to show us, and this is probably good for everybody to hear, in number 3, so number 3 takes this to the next level for sure. Okay, number 1, relatively easy. Number 2, almost just as easy. But number 3, because the only rational zero that we find is a fraction, negative 2/3, there's 2 approaches that you can have. And although you might like one more than the other, I'm cool either way, but you have to see this in action and know that there's really only 2 possibilities, okay? You can use synthetic division with that number. And I chose this function on purpose because it still works out nice. And maybe you're not great with fractions and multiplying fractions together, but your calculator can help you do that. But it does work out nice. You get this quadratic, 3x squared minus 6x plus 12. Okay? And so it could factor like that. And that's fine. Okay? But maybe you say, you know what, I don't like dealing with fractions. I'm going to go the long division route. But to do that, in order to avoid fractions, I'm going to figure out the factor that got me. Okay, that's 3x plus 2, and then you work through this whole thing, and there's the result. And so it maybe instead factors like that. Okay, now, and I'll get to your question here in a second, but what I want us to realize that these 2 are definitely the same. what we want to be careful of is we're not like making this function up, right? This has a leading coefficient, and I cannot change how big this function gets. And so what I saw some people do during second is they did that. They took this that they didn't like, right? And I said, go ahead, multiply through by 3 to get rid of that fraction, right? We did that a couple weeks ago. And they rewrote it like that, which is so nice, right? That's the better version of that factor. But that multiplying by 3 doesn't just happen out of thin air. That's got to come from somewhere. There is a common factor of 3 in there. And so if you want to get rid of this fraction, you can't just magically multiply by 3 if we're coming from a function. You can't make things magically 3 times bigger. You have to take this common factor of 3, factor it out, and multiply it. Okay.
So is it necessary to even divide, or could you just factor out 3? Like, is it necessary?
So you're here talking about?
I'm talking about that, yeah, how do you divide that? It's not even necessary if you can just factor out 3.
So are you saying, can I just do synthetic division, notice the common factor, and use it?
Yeah.
Absolutely.
Okay.
That's what I would do. That is absolutely what I would do because I love synthetic division. I am good with fractions. I can multiply fractions together pretty easily. That doesn't bother me. And I can also notice that there is that common factor. And look, if there aren't any rational coefficients, like any fractional coefficients here, then there shouldn't be here either. Right? I should be able to get to a point where if I did have a fractional answer, that denominator is a common factor in what's left. Absolutely. So if your style is to say, you know what, I'm going to go for it with synthetic division. I'm going to pull this out and go from here to here and not even worry about this. Absolutely. This is for the people that say, you know what, I don't like dealing with fractions. I totally get that. And polynomial long division is going to work. It's going to work really well because it avoids fractions the whole way. And if me, your teacher, pick a good function to work with, we should get nice results. And that's what I want. I don't know if that answered your question. Yeah. Okay. But 3 takes it definitely to a whole nother level. And that's why I put it in there relatively early on so that you get used to seeing not such great looking answers and realizing that that's okay. That although they're ugly, they're not. They're beautiful and they're perfect. Yeah.
Yeah, look at number 3.
It's close, not enough to lose points, but not extending that square root cover, it seems silly, the parentheses. I would never take all points for that, but if you stopped a little short, like before the 4, but that's just like being super, super, super. Okay. 1 plus or minus this. 1 plus or minus this. 1 plus or minus. You're just simplifying the stuff that you know you need to simplify, but you forget to complete. Okay. Open parentheses, close. This factor's done. Open parentheses, open parentheses. You have 2 now to close. The inside one and the outside. Same thing here. You need 1 more parentheses to close my full factor. Now, yep. Let me come back to green just for a second.
Oh.
So back to second, because I don't know if I made it all the way. Or if I answered.
I think so. I just was like, oh, that doesn't look very good.
It's tricky. And that's why I put the solutions together. So that if you do get to something like this doesn't seem right, let me see if that's happening. Always go back. Good. arrows.
Oh, but
It's just a style choice for you, and I totally get that. And so it doesn't bother me as much as it might bother other math teachers, because arrows are not equal signs.
yeah.
It's a sign of implication. It's like I have this, and now because of that I can say this, and it's like it's not an equal sign.
Yeah.
And what you really mean there is an equal sign. And that's just super picky notation stuff that I probably would just
I should put
like hurt a little on the inside, but not like knock you down for it.
Yeah.
But you want to start saving your arrows for when we actually moving towards something.
That's so
Because when we get to calculus, we're going to use arrows.
Really?
Yeah,
I
and
love
not-
her.
Oh, good. But they're going to mean something different. It's not going to mean equal to, because preview of calculus. Can you actually go to infinity and stand there and be there and say, here I am, I made it?
No.
We're going to go there. We're going to go in that direction. Okay, so that's going.
Got it. Thank you.
How are we feeling? Pretty good? Cool. I would put equals 0, and then x equals, so I know you have an equation, and that you're solving. Okay. That's just more of a notation thing. So no, x equals. So you're finding the solutions. So put an x equals, put a equals 0 up here, right? Because you're finding the solutions to that quadratic. You're finding the x-intercepts for that one, and because it's not factorable, you do the quadratic. Okay. As you work horizontally, I like that you have your equal signs there, but if you're dropping down vertically, put an equal sign at the front there too, so I know that it's just kind of like typewriter continuing from the line above. Okay, cool. And then same thing here, right? You move vertically, put an equal sign in front there. This way I know it's x equals. And you can always put x equals, that's cool, but if you just put the equal sign, then I know you're continuing your work. Okay, but you're not starting. All right. All right. Now we go. For D, you're like your partial factorization there. Since this function is f of x, put like f of x equals. Okay. So I know you're looking at rewriting the same function, not doing something different. So drop in f of x equals. Because you did that for part f, which is good. And you did it there. Nice.
No, I did.
Oh, did you? Okay, nice. How you feeling? You good?
Yeah.
I would get rid of those intersets of parentheses.
Okay.
To write just the simpler version of that.
All right.
Right. Take it from there to there. I think that just adds just a level of simplicity that I think is worth. All right, Mr. Fry.
Okay. Yeah.
We're back to the.
This is like a really funny thing. Oh, okay.
For B and C, I might say like x equals plus or minus all this stuff, and x equals 2, so that I don't have to look back at the question to know what you answer. Like you want your work to stand alone, I guess I should say. So just a little x equals handy. And as you get more comfortable, I don't need this step. I don't need that step. If you feel good going from there right to there, do it. Yeah, sure. This was good. Yeah, x equals 2 equals. There. Good, equals 0. It's not that 0 equals this. X equals this. So change that to x. Solving that unfactorial quadratic. Good. I like it. We're looking pretty good. We are coming towards the end here, so if you want to find a decent stopping point, which might be like 2 minutes ago, that's okay. And just start working through this, but as you start to close up, just take a look for a second as I scroll through. 3 gets a whole bunch harder because you have this unfactorable quadratic and you don't have a perfect square underneath that square root, so you have more simplifying to do. Okay, 4 has some repeated zeros, which you won't notice unless you graph. Okay, so make sure you're looking to see what that graph is going to look like to help you factor, but the rest of it kind of works out nice. Okay, 5 is crazy, but so much fun. And it works out real nice until you get to that quadratic, and it doesn't simplify with the denominator. Okay, so it's gonna get a little rougher, but those are correct. Okay, 6, 7, 8, 9, and 10 shouldn't be too bad. Okay, but what I want you to notice with your last couple seconds here is that once I get really eyes, I'm done. You want to keep going, that's up to you. That standard form, you don't have to because I didn't ask for the standard form. I just wanted real coefficients. I even got to the point after 8, because 8 was crazy. I was like, I am done multiplying this stuff out because 9 and 10 just get tougher. Okay. So take tomorrow and work on this. Come and see me at office hours if you want to ask any questions. Expect some homework this weekend for Monday or Tuesday, depending on where I see you. When can I see you again? Bye, everybody. Thank you. Have a great weekend. I will catch you later. And everybody at home, thank you for being here. Any questions? Any leftover stuff here? And hello. Anything that I can help you with?
I had a quick question.
Yeah.
I just want to make sure that like I'm not okay. Anyways, for like the number 3 for F,
Yeah.
when you break it into that X minus part, like, and then the complex part,
Yeah.
you have to have that step, right? That X minus and then the imaginary number in the parentheses.
Yeah, so we've got this like inside. Oh, I even forgot it. There should be. I don't know if you can see my cursor here. There should be a second set of parentheses right there, because I've got like X minus whatever my answer is, right? Whatever my complex solution was, which happened to be one of them was 1 plus a square root of 3i, which is gross, but it is what it is. There should be. I can't believe I forgot it. There should be a set of parentheses, a second set of parentheses right there, closing off this second factor. Now, I don't need you to specifically write that, as long as you make sure you get down to this bottom line where you have indeed subtracted that complex number, both the real part and the imaginary part. So if you know to switch the sign, I'm cool. You know what I mean?
Okay.
I don't necessarily need this first line, as long as you have the second one.
Okay, and then is it just always X minus? It's never X plus?
It's always X minus your complex root. Because if we look back at the linear factorization theorem, what it tells me is that because my answer X equals 2, okay, so X minus 2 is my factor, right? X equals -5, okay, X plus 5. So if you mean like there's never going to be a plus sign, that's not necessarily true. It's always X minus my root. And if my root is negative, minus a negative is going to be a plus, right? And so when I look at solutions for, even for this one, I mean, there's a plus sign right there, for sure.
Yeah.
But I'm always going from X equals, C sub k, whatever, it's, some complex answer, to X minus that number as my factor, and just switching signs as I go to make sure that the factor would get me to that 0.
Okay, that makes sense. Thank you. I was just like, when I first saw that step, I was like, wait, what? So,
right.
Okay.
It's because of that right there, right? That linear factorization theorem, which makes sense because if I want X equals 2 to be an answer, it's X minus 2 is the factor, right? I always switch the sign, which is subtraction.
Okay.
Yeah, I had that same question because, like, let's say for just number 3, if F was like, if we got, instead of X equals 1 plus or minus 3i, if it was like X equals -1 plus or minus 3i, would we have to do X plus then?
Yes, exactly. So if you had -1 plus or minus radical 3i, So we have some factors, whatever they are, but then, so for this one, right, because we have, sorry, let me turn this, right? So you have -1 plus radical 3i and -1 minus radical 3i. So one of your zeros is x minus one of those, right? And the other one is x minus the other one. But this first one is -1 plus radical 3i. So you're going to end up as x plus 1 minus radical 3i. All right, this one is -1 minus radical 3i. So we really do, you're right, x plus 1 plus radical 3i. Absolutely. It's all about the signs of your zeros all switching when we go to the factor. And we never really had to worry about switching lots of signs because we only had the real solutions, right? 2 and -5 and 1/3 or whatever it was, we just switched the sign. But now that you have these binomial complex solutions, we just want to make sure we switch all of the signs, right? The real part and the imaginary part. So that's why we drop it in parentheses and put a minus.
Sweet. Do you have time for one more question, or should I just do office hours Friday?
No, I have lunch. Let's do it.
Okay. I was just confused on. I was really just comparison between 2 and 3 for E is what it is, because I was confused when you get rid of the square root, because the answer for E for problem 3 was 1 plus 3i or 1 minus 3i, but there's no square root. But then for 2e, there is a square root. I think I'm just confused when we get rid of that.
Okay, so go, I mean, if you're looking, I should be, am I sharing my screen right now?
Yes.
So if you look at my result for part E, I have this quadratic, it's unfactorable, so I go right to the quadratic formula. And however that quadratic formula works out, kind of decides what's going to happen. And so when I look at what happens underneath the square root for 2e, I get the square root of -36. And the negative under the square root is just the I, right? So I can pull that negative out and make sure I have the I instead, right? Because that's the square root of -1. So really the only thing I care about when I'm simplifying these square roots, number one, of course, pull out the I if it's something negative, but really I just care about the number itself, 36. If that number, whatever is under my square root, once I get rid of the negative, is a perfect square, then I'll just take the square root of that number, right? I have the square root of -36. I pull out the negative as I pull out the I, and I think about the square root of 36. Is that a perfect square?
For 36?
Yeah.
Yes.
So I can take the square root and call it 6 instead, right? The square root of 36 is just 6. Not the square root of 6, but just 6. My radicand was a perfect square, so I can drop the square root. But when I go down to something like number 3, and I see what's under the square root when I do my whole, when I simplify the discriminant with b squared minus 4ac, I get the square root of -12. And sure, I'll pull out the negative as I pull out the I, but I just look at the square root of 12. Well, that's not a perfect square. And because my radicand is not a perfect square, I know I'm going to end up needing to hold on to a square root if I'm going to write this answer, because I just can't take the square root of 12 and end up with a perfect number. And so I kind of took my time here with E, where as I go from this step that I'm circling right now with the square root of -12 to this step, I just pulled out the -1, right? To remind myself that I can do that because that's going to be my I at the end. But the square root of 12 can be simplified by pulling out that perfect square factor of 4. Right? I can break the square root of 12 down into the square root of 4 times the square root of 3, which is 2 root 3. Now I still have that I attached at the end because that was the negative part of that radicand, that square root of -1, that becomes the I. And as I simplify this fraction, I get to do the 2 over 2, right? The first number here over the denominator, which is just 1, plus or minus, okay, plus or minus. And then this 2 gets divided by this 2. So those will cancel out, and I'm left with the square root of
Okay, that makes more sense. I think my main problem is like when I got to the square root of -12, I tried to
Right.
do 6 and 2, and I think that just messed
There you
me
go.
up. I didn't do,
Right.
yeah.
So when you break it apart, the whole point of breaking it apart is so that one of those factors is a perfect square, because then we can at least drop the square root from that one. Right? Square root of 4 is perfect square, so I can just call that 2 instead.
Okay, yeah, and I didn't even think about how 36 is, like square root of 36 is just 6, because then I tried to break it up 6 and 6, and then I had like -3 and 2, and then like it got the
Right, yeah.
same. It was just, yeah, okay.
So you were doing more than you really needed to. And what I tried to do by putting these questions in this order is take the easiest one and put it first. And then kind of the next easiest where, all right, I still need the quadratic formula, but it works out really nice. Okay, cool, that's number 2. But then number 3 is, oh, I need the quadratic formula, but it doesn't work out quite as nice as I wanted it to, so I still have that square root part of my answer. Right? And then you'll get to 4, and you're gonna see, well, you know what, this one isn't quite so bad, but I have repeated zeros. And so I wanted to throw that one at it too, so that you know to go looking for them by looking at the graph. Because if you run through your list and you say, okay, I gotta find 4 complex zeros, and I know they come in pairs, so if I find one rational zero, man, I better find another one somewhere. But you wouldn't know that by looking at the table, right? Because if you only get 2 back as a 0, that's only 1. But if you look at the graph, you'll see that it hits x equals 2 like a quadratic, right? So there's that multiplicity of 2, which means I can do synthetic plus. So that's like that little thing that happens in 4, and then 5 is crazy. Do 5 if you want. It's a challenge. It's not that hard. Like there's this repeated zero, so you can do repeated synthetic division. But it's just that the quadratic formula just works out kind of gross. But I just wanted to show you that can happen, right? And it just is what it is, and that's the best version of that answer. So it's a good challenge to push yourself a little bit further and make sure you can do it all. Because if you do that one, man, you can do it.
Got it. And then with those reducing square roots, will it ever not have a perfect root to go with it?
For sure. And take a look. I mean, that's number 5. When you look at what happens with number 5, it's the square root of -11. Okay, that's the square root of 11i, and there is nothing else I can do about that. Cool. Let me stop.
Okay.